because I told him I've been talking to you for like about a month. Whenever we started the sessions, I told him that day.
Yeah.
I was like, damn, Burr's like a low key teacher up in this bitch. Like,
For a long
straight.
time, I wanted to be a teacher, like Japanese, or teach English in Japan.
Yeah.
Yeah.
Yeah, I was saying, I was like, dude, I was like, both my friends are straight up teachers. Like, hey, have Jordan teach me the Japanese, and then
Yeah.
teach engineer. I was about to have to put both of your names on my bachelor's.
The EE bachelors will serve you well, my friend.
Yeah, most definitely.
Especially around here. Like if you can get into the big name companies, there's risks of layoffs and shit like that. There's
Hmm.
politics and bureaucracy. But otherwise, you make hella bank.
I'd satisfy working for my current company initially as
Yeah.
an engineer. Yeah. I'm sure if I was an engineer, they'd take me. But yeah,
Yeah. And they might not pay quite as much as the big company, but they
totally.
still probably pay pretty damn well
Yeah, they pay enough for the MEs to complain.
to complain.
Yeah, because the MEs are always complaining about how the EEs make more money.
Around here they do.
Yeah.
And the software engineers make a little bit more than the electrical.
Yep. Because I'm about to say, then the EEs complain about the software engineers.
Yeah.
And then they're all complaining about the project managers because they're like, these motherfuckers don't even do engineering and they're making money.
The project engineers and the PMs, they make almost the same base salary, but they don't get any of the sign-on stock and stuff.
Yeah.
So
But even that's enough for MEs to complain. It's like PMs get well because the PMs, they get remote days, whereas it
hmm
makes more sense for EE and ME to be in office doing whatever they got to do.
yeah. Well, at least with what I do, I don't even need to be in most days.
Yeah, that's how the EEs are. They're only in 3 days a week, whereas the MEs they're in every day because it's like,
Yeah.
what are they gonna do? Except do drawings online.
Yeah, they can do CAD all day, but
Yeah.
even that, I can't imagine you can go too far without at least generating a prototype or a 3D
Hmm.
print.
Most definitely.
But like, for the majority of, was it 2 years ago now?
Hmm. Huh.
Oh fuck! For the majority of 2 years ago, from about May or June 2022, for 3-4 months, I had zero reason to go into the office.
Yeah.
I still did 3 days a week,
Hmm.
4 days a week, but for the whole time, I was just doing board layout. And that's just all in a tool with a board layout engineer. And I'm like, hey, move this, move that, move this, make that bigger.
Use Altium or some proprietary.
We use Cadence Allegro.
Okay.
Yeah.
Yeah, we use
It's
Altium.
Altium is like tier two in overall greatness,
Hmm.
but it's tier one in ease of use. And then Cadence is like tier one overall greatness, but like
Robust as hell
tier,
features.
yeah, but like tier four in ease of use.
Yeah.
This shit
Fuck.
is hard to learn, but once you learn it, it is just a gorgeous tool.
That's crazy because I'm like looking at Altium sometimes, like, bro, how the fuck do I use this shit?
And I still don't even know how to do most of the layout shit because we have layout engineers, and I just sit with that guy and be like, do this, do that, move
Hmm.
this. Like literally for the first 4 hours of my day for like half a year in that year, it was just me going through and with the layout engineer for 3-4 hours a day.
What is a layout engineer like by degree? Mechanical?
I asked him the same thing, and there's not really one actually.
Oh,
You just need a degree and be technically savvy.
gotcha.
I
Okay.
think he has. Can't remember if he has an EE degree or just got into it some way somehow.
Hmm.
But are you ready?
I'm ready.
Okay, so let's do this. You want to just walk through the questions? You should be able to do question 1 through, what was it, 6 or something?
Yeah, 1 second. 1 second. Let me pull
One
up.
through seven should just be pretty fucking easy.
Yeah, easy to you.
Easy for you too. Well, you and I have done that like 4 times now.
Dude, you know I have like a soft reset every time.
Yeah.
Lab Q. Yeah, this example video was like the worst because it's like I don't even have two voltage sources in this example, man. Like, come on, man. Cut me some slack. Anyway, okay. I've got it up. Oh yeah, let me pull up when I was working on it. So initially, this is running in a series, yeah?
Yeah.
So R total would be R1 plus R2 plus R3. VT is 12 volts. RT is 3.6. Wait, no, 5.6. You go in the office this week? Today?
Yeah.
Yeah.
Yeah. I go in Tuesday, Wednesday, Thursday. I'll go in Monday and Friday if I have absolutely the need to do it, which it happens maybe 10% of the time.
Mm-hmm. 2.143 milliamps. So IR1 would be 12 volts divided by. Oh, wait, no. IR. Wow.
You got it.
That would be.
So I heard you say it. We have I
Yeah, IR, so that'd
equals
be 2.143
143 milliamp,
times. Yeah, milliamps. Times 1.2 K ohms.
which is
2.572 volts. Let me turn on my lights real quick while we're trying to do this shit in the dark. Be right back. I like ran and came straight to Discord.
it's fine.
Yeah, 1 second. So IR1. Wait, what? Did I do it
But
wrong?
so far, you've said
It's
everything
supposed to
correctly.
be multiplied, right?
What is multiplied?
2.143 milliamps multiplied by 1.2 k ohms. Yeah.
Yeah,
All right, let me do that again.
you said the right answer just a minute ago.
Times 2.572. That doesn't sound. That doesn't look right. It's asking for milliamps. 2.572.
Ah, you read the question.
Calculate the current
Uh huh.
through R1. Oh,
Uh huh.
but it's a series, so it all stays the same.
Yep.
So it's 2.57. It's already 2.143.
Yep. You're jumping ahead.
Yeah, that's
Which
VR1 that I just solved. Right?
yes.
Yeah.
Yep.
Sneaky, sneaky, sneaky. And then every IR is 2.143. So I hate when he does this because this shit like it feels like such a trick question because I'm like, man, there's no way this is all the same answer. Like, there's no way.
Mm.
And even when it is, I still don't believe that it is sometimes.
Mm.
All right, so 2.143 by multiplied by it.
I'm going to respond to a couple messages
Go
while
for
you
it.
go.
Yeah. 4715. Did you get 4.715 for VR2?
Yeah.
And that's VR3 as well then. Measure the voltage across VAB. Now that is voltage divider rule, which is
Hmm. Interesting.
what did you say? Interesting.
Hmm. You could solve this with theory. You don't need to do any calculation.
What's the theory?
The theory is you've already done the calculation.
I knew you were gonna say some shit like that. What does that even mean? Wait, let me double check what this question is asking for again. VAB. Voltage across A and B. Oh, so that's R3, right? That's the voltage across R3.
Mm-hmm.
And that's VR3. Oh, that's 4.715. Oh.
No.
Was that the theory?
Well, the reason why that theory works is because this is ground.
Oh, that's true. If there was no ground, what would happen in that case?
You'd have to calculate the voltage drops all the way across. You'd have to say this is, like 9.5 or
Mm-hmm.
whatever, and then this drop here is, what is that, 4.7. So this would be 4.7, and then you'd have to do the next one and so on.
I see.
You could also add it up too.
Yeah. Because I'm
Like
just seeing it now. I had the 4.7 plus the.
if you wanted to solve for this, we'll call it Z here.
Mm-hmm.
You knew these two voltage drops, and you knew that this was ground, so you'd get 0 plus 4.7 plus 4.7, right?
Oh.
So you know that the voltage there would be
Yeah,
9.4.
9.4, yeah. Damn.
Oh, I should have done this so I can get those red marks off of there.
Oh, yeah. Control Z.
Yep.
Smart.
And so this is 4.714, and then this is 4.714. Yeah?
Mm-hmm.
Okay.
So now the V Thevenin.
V Thevenin. All right, here we go.
So
This is where I.
now,
Right?
yeah.
Okay. None of this other thing was hard, right? This was easy.
Yeah, all that was easy. I just moved slow. Yeah.
There's nothing wrong with moving slow. Let me tell you something. Getting it right means more than going slow.
Fair.
Um, like a lot of the times, it doesn't matter how you get to the answer, as long as your answer is correct. And it doesn't. And in general, even in my work today, it doesn't matter if like I take extra time as long as I get the answer.
Yeah,
Obviously, there's some balance there.
for
Like I
sure.
can't take a week or whatever, but to do something that should take me
Yeah,
a day.
deadlines considering.
Yeah, yeah, yeah. There's some practicality to it, but especially as you become a junior engineer in a company, they're not going to give you like this hard fucking problem and say, "Hey, get it done tomorrow."
Yeah.
They're going to give you something. Ideally, they're going to give you something you can chew. And yeah, it might take you a week to do it the first time, but then every time after that, you'll do it in a day or two.
Mm-hmm.
So, um, okay. So the Thevenin resistance here,
Yeah.
Thevenin voltage. So, all right. The Thevenin equivalent voltage. The reason I don't know how to do this one is he says if a load resistor is placed across A and B,
Mm-hmm.
well, it doesn't tell me what the load resistor value is.
Right.
and so like I understand what you're supposed to do, and maybe we should just go through it, and maybe the going through that process will awaken something in me, and I will remember what the fuck to do.
Hmm.
Okay, so let's redraw this circuit. How do we do Thevenin circuits here? I'm gonna draw the resistor. You don't mind that I put the resistor up top instead of on the side,
No, I
right?
don't mind.
Okay. So we have something. I'm gonna put a small break here just to show that it is something we inserted into the circuit.
Hmm.
And we got 2.2K. What do I do with the voltage source in this case?
We'd short it, so you just do a wire. Yep.
Here we go. All right. And then, so I want to say this in a way that we use in the real world. Okay. I
Hmm.
don't know if I told it to you in this class. What we want to do is look at the equivalent resistance. So basically the REQ
Hmm.
from your resistive load's perspective. Does that make sense?
Yes, but what is a resistive load? Like, where does this load resistor just come out of? Is this something in the real world? Would this be something that I'm putting? Like, what is it?
So yeah, so realistically, it would be something you're doing. In my line of work, this would be your CPU or your GPU.
Oh, okay.
You can model your CPU and GPU as a resistive load if you want. It would be kind of a stupid way to do things, but you could do it.
Hmm. What is a
Realistically,
practical way to use a load resistor? What would a practical load resistor be?
charging a battery.
Hmm.
So you, this is known technology. You don't really know what diodes are yet. You might have heard the word,
Yeah, I've
but
just heard the word. Yeah.
you don't know how to use them. This is a real world circuit. Um, so this is called a full bridge rectifier.
Yeah, I do know. I was about to say this looks like a bridge rectifier.
Yeah, full bridge rectifier. And then we have, fuck, do I remember how to do this? Maybe not. Oh, yeah. So we have one line coming in here.
Hmm.
It'll call this V1 and then a positive and V1 negative. And if this line goes over that one and comes here. This rainbow thing is shit for this drawing.
Hmm.
Okay, something like that. All right, and so let's say this is, we'll say it's 5.07 volts. Okay,
Yeah.
it goes to this full bridge rectifier, and then this voltage here becomes 5 volts. Oh, I'm sorry, 5. Damn it. Do the thing, pen. Come on.
Just
Do the
Control
thing
Z
where
it.
you work.
You're not that far
No,
away.
I'm trying to erase, and
Yeah,
my
I know.
pen's.
You got to click the eraser.
No, so I'm supposed to be able to turn the pen upside down and erase. There it goes.
Oh, that's right. You're using a physical thing.
Yeah. So this is 5.7 volts. Sorry. Okay.
So where does the
And then
700 millivolts go?
it drops in these diodes,
Okay.
um, which is why I was saying you don't know much about diodes yet, which is fine.
All right.
And then, so then typically this will go into some sort of voltage conditioner. Typically, we call them an LDO if it's low current.
Okay.
And for the sake of this is still going to be 5 volts.
Okay.
Okay. And then this will go into like a charger. And this charger will charge a battery,
Hmm.
which will also go out to the V system, the voltage of the system. Okay.
Okay.
So what you can do is say, well, my charger will charge at 25, that's a 2, 25 milliamps.
Okay.
Well, 25 milliamps at 5 volts is what in resistance?
Let's-
125 ohms.
Wait, 25 divided by. Oh, yeah, I did it wrong. 5 divided by. Let's try to be fast. Yeah. Wait, what? 5 divided by 25 milliamps?
Did I get? I might have done that wrong.
5
The
divided by
150,
25 e negative 3 is
25.
200.
Oh, 200 ohms.
Mm-hmm.
200 ohms. So one thing about chargers
Mm-hmm.
is they do not act linearly.
Oh, okay.
So if I'm trying to tune this circuit over here where V1 and V2 or V1 plus and V1 minus comes in, it makes much more sense to break this charger and put a 200 ohm resistor here.
I see.
Does that make sense?
Wait, why?
Because the charger behaves nonlinearly.
See, that I don't know about linear and nonlinear.
Basically, if we look at what a charger does, this is time,
Mm-hmm.
and then this will be milliamps. Okay.
Yeah.
We know that it is capable of 25 milliamps max.
Mm-hmm.
But as voltage comes in, let's put 25 here, we'll put 12 here, and that'll be 0. As voltage comes in, it might come up here, and then, oh, maybe the battery doesn't need it as much, so I'll come in here
Oh.
for a little bit and there for a little bit. But I need to tune my circuit way over here to 25 milliamps.
Mm-hmm.
Okay? And so therefore, it's much easier to put a 200 ohm resistor there.
That makes sense. Gotcha.
Sound good?
Yeah, that makes sense.
Yep. And you can do this
Because
in,
every time I hear load resistor, I'm like, what the fuck is a load resistor? Like
yeah.
what is this shit?
Another thing that they use it for, granted, we use electronic loads more these days, which
Mm-hmm.
is basically an electronic resistor. Let's say you have some power supply or switch mode power supply, and it's got some VBAT input, and it puts out, I don't know, 5 volts at 10 amps.
Mm-hmm.
But it is capable of doing that. But your system only requires, like your system requirement is 5 volts at, I don't know, 7 amps.
Mm-hmm.
And that seems reasonable because that gives you 3 amps of overhead in case something goes wrong or
Right.
something, small peak that goes up real quick, right?
Totally. Degradation or some shit.
Yeah, but what some people will do because you want to know how robust your system is, they will add, so they'll add,
Do a what?
they
Add.
want, yeah, they'll add.
Your voice was buffling out every time you said add.
Oh, weird.
Yeah.
They'll add,
Again.
again, 3 amps
Yeah.
of current to the system to watch this and make sure that this switch mode power supply
Got you.
can handle it. And you could just tack a resistor in there if you wanted, do the calculation to get you 3 amps. I bet you'd have a hard time physically finding a resistor to push 3 amps through without it being fucking massive. But yeah, that's exactly what a load resistor is, and you'll get an E-load, electronic load, E-load, and it'll be capable of doing that. God, that's horrible. It'll be capable of doing a lot of things. It'll be capable of like switching that load on and off real quick. You can
Like a
stress.
like a switch potentiometer type shit, or no? That doesn't really switch it on or off. That just changes the resistance, right?
Yeah, right. It can switch it on and off. It can switch it to a different resistance. E-loads are capable of a ton of things, and usually they're used to test systems and make sure they're robust,
Mm-hmm.
or brutalize systems and see where they fail.
I see.
We have this thing. You can ask one of your EE buddies at work about it. DFMEA, or sometimes it's called FMEA.
Yeah.
Um,
FMEA. Why does it sound familiar?
there's also another. There's FEA as well.
Yeah.
These two,
Failure mode and effective analysis. Yeah.
yeah, exactly. And then the D is just design failure mode effect analysis.
Mm-hmm.
And then this one is finite element analysis. So
These are like drop
kind
test, shock and vibe, thermal tests, and shit like that.
DFMEA, yeah.
Yeah.
The way we do it for at least in Microsoft is like we intentionally put a short somewhere it's not supposed to be
Mm-hmm.
and see how the system reacts.
Oh, I see.
Yeah. Usually with a thermal camera to see if anything gets a little too crispy.
Yeah.
Okay, where were we? We got off topic
Yeah,
here.
we totally did.
Uh, okay, I'm gonna redraw this down here. Get away from all this.
Oh yeah, V Thevenins. If a low resistor is placed across points A and B, calculate V Thevenins equivalent voltage.
Yep. Let me rewrite this here. 1.2K, 2.2K, 2.2K, A, B. I'm gonna label this Z, just so it has a label. I like labels. And then we have our load resistor here, RL. Okay, so we want to know what the resistance of the circuit looks like from the perspective of the load resistor, right?
Yep.
How do we do that? What does that look like?
I don't
Can
know.
you don't know? Can you help me draw an equation, write an equation? Let me ask you this. Oh, where'd it go? This one here. If I put a voltage source here, if I made this, a battery like that, and asked you to tell me what the equivalent resistance is from the battery looking out, you could do that pretty easily, couldn't you?
From this one battery and not both?
Yeah, we
Yeah.
would short that.
Yeah, I could do that.
Okay. Well, then what's stopping you down here?
So what would I do? I would put a battery there? Or I would just measure the
No,
resistance.
pretend it's a battery and
Hmm.
tell me what the resistance looks like.
The resistance looks like oh.
So we're looking at it
Oh.
this way, right? We're looking at it this way.
But now it's parallel where it was a series, right?
Yeah, yeah, exactly. So what does my equation look like for our Thevenin here? Can we just write that real quick?
What is that? 1.2K in
Our-
parallel with
Hold on, let's write the equation. Let's not write the numbers.
okay, yeah, I was looking for the the
All
resistance.
right.
Yeah, it's all good. Um, so it would be all right. And it would be R3 plus R1 in parallel with R2. Oh wait, no, it would be R3 in parallel with R1 plus R2.
There we go. And we want to make sure that we write this correctly. So definitely make sure you get your parentheses right.
Yeah.
Okay. R2. That is exactly right. Okay, now we can add numbers here. So R3 is 2.2K in parallel with this is 3.4. Okay.
3.4. Yep.
Okay. So what's our R Thevenin? I
So
don't have it calculated, so
2.2 E3 times 3.4 divided
okay. I got a number now, so let me know when you get yours.
by. You did that shit in your head.
No.
Oh, okay. So what the fuck? 1.336K ohms.
Yep. 336K. Good job. See? You got this shit, bro.
Dude, it's because you're helping me, man.
I mean, it doesn't matter if I'm helping you or not. I just asked you to do this equation, and like, I don't know, 3 weeks ago you're like, "Durr." Now you're
Yeah,
fucking
fair.
got me, right?
Fair.
I'm not trying to be rude. I'm sorry.
No, you're not being rude at all. Wait, so that's the total resistance.
That is the R Thevenin
Our Thevenin
resistance
resistance, yeah.
from the resistor looking outward.
Hmm. Now, how do I get the voltage, though?
Yeah, that's what confuses the fuck out of me.
Okay.
So what I yeah. Oh, you son of a oh, he's tricky.
Dude, he is tricky, man.
I figured it out. Okay, so a Thevenin circuit, the
Hmm.
basis of let me use black here. A Thevenin's, God damn it. A Thevenin circuit,
Yeah.
by definition, is a voltage source in series with a resistor. That's it. And then you have your load point, your R load.
Hmm. Oh, so it would
Okay.
still be the same. No.
No. We know our voltage source
Hmm.
is 12 volts, right?
Yeah.
Son of a bitch. 12 volts. We know what our R Thevenin is.
Yep.
We also know our current, do we not?
Yes, we do. 2.143 milliamps.
I equals 2.143. Is that right?
Yes,
Yeah.
milliamps. Hmm.
Milliamps. Our R Thevenin is 1.3
1.336K.
A.
Oh,
So, maybe we don't know our voltage source, but we know our I. Wait, does this make sense?
it makes sense, but I don't know if does it work like that.
See, this is the thing I don't remember. This one little portion that I just do not remember.
Because it would be 2.863 if we multiplied those together.
2.863 volts.
Volts, yeah, it would be go to straight volts. If you did the milliamps times the kilo ohm.
That's the voltage drop.
Oh,
2.86, I think you said, from there to there. So that means if this was 12 volts, we would have about 9.14 here, which doesn't make sense because if we looked back earlier, we had 12 volts here, 9 point something,
9.4,
9.4, sure. And then this was 4.7,
7. Yeah.
like that, right?
Mm-hmm.
I would expect if we add a load here, that means this volt the resistor REQ goes down.
Mm-hmm.
So that would mean more voltage would drop up here. So I do not think that is the right answer. I think we're missing how to calculate this voltage of the source. I think the voltage of the source will be slightly different, and that's the part I'm confused about.
Right, it's got to be.
Hmm.
Yeah, I'm like, man, how the fuck do you get V7? And the lab that I was having a problem with in class is asking for the R Thevenin, so I didn't even think about asking them for that shit when I was just in lab today. Yeah, I was just like, man, how the fuck? Remove the load resistance. Measure the open circuit voltage. Yeah, how do I measure the open circuit voltage across terminals? How do I calculate that though?
What are you talking about? Across A and B? Which question are we talking about?
I'm reading off of some EE Power website.
Oh, okay.
Yeah, it's not exact.
How do we solve the voltage Thevenin? I of the load equals voltage Thevenin over the resistance Thevenin plus the R load. No, it's not what I want. The voltage Thevenin equals I of R. Right. Fuck you talking about?
Yeah, do you know? And then the Norton one is the other version that we have to learn. That we don't have to learn, but it's like the opposite of Thevenin. So,
Well, so the only thing I remember from Norton and Thevenin is transforming a voltage source to a current source,
hmm,
which is really easy to do. But I don't remember how to do this shit
yeah.
for the last step. But we don't have VL. We don't have the resistance of R.
Thevenin's equivalent is any linear electrical circuit voltage is replaced by terminals A and B by an equivalent combination of a voltage source, Thevenin, in a series connection with a resistance. Voltage attained at terminals A and B to the network terminals A and B is open circuited. If terminals A and B are connected to one another, the current flowing from A and B will be V Thevenin over R Thevenin. This means that R Thevenin can alternately be calculated as V Thevenin divided by the short circuit between A and B when they are connected together. What?
Let's
If only
see.
that sentence made sense to my smooth ass brain.
It's just
If terminals A and B are connected to one another, the current flowing from A and B will be V Thevenin divided by R Thevenin. This means that R Thevenin could alternately be calculated as V Thevenin divided by the short circuit between A and B when they are connected together. Let me try and draw this shit in, what's it called?
multi.
Yeah, multisim. Oh, I got the other one in here. I was like, what the fuck is this?
Like, I feel like this is one of those problems we can solve without the actual load resistance. I just don't remember that step.
Well, shit, if you know how to solve it without the low resistance, I mean,
I think you can. I think we have what we need. I just don't remember how to do it.
totally. Welcome to how I feel about this class all the time. That's why I run to you, dude. I'm
Yeah,
like,
yeah.
I feel like I got it all, but I don't. Yeah, it's funny. I was just talking with him on one of the EEs at work, and he was like, "Have you decided on if you want to like do EE, ME, or some other shit?" And he was like, "Yeah." He was like, "I was like, I don't know. It's still like all up in the air because you know." He was like, "Yeah, because EE's like still believing in magic or some shit like right that." And I was like, "Yep."
I mean, you can still make a good living software or mechanical engineer.
Software is even harder, dude. I was trying to do computer science before I was trying to do EE a long time ago.
I I don't know. It's different. I'm not necessarily certain it's harder.
I mean, you're already mad smart, so yeah, that's just like this shit's all easy to you. You're a fucking like nuclear physicist or some shit.
Well,
Bruce Banner.
thank you for the vote of confidence, but I disagree.
Hell yeah. Yeah, I was told actually I was told the same EE at work. I was like, yeah, my friend. He was like, yeah, once you get to like Calc 2, it'll all just click. And I was like, yeah, maybe then I'll know really which one I want to do. But I was like, he said that though, like Calc 2 is like easy as hell to get to. I was like, bro.
Yeah, it is. It's not bad.
Yeah, that's what you said. I was like, can't believe this guy, man.
You can solve for areas of a square and like a triangle and shit. You can do calc too.
Fair. All right, let me put this resistor or this load on this shit.
Calc one is where the real theoretical stuff comes in, and once you understand that, though, the rest of it is just gravy.
Well, shit. Okay. 4.714 volts when I measure across
Yeah,
points A and B.
that's what we calculated.
Oh yeah. So that is the answer to question 11. But would if a load resistor is placed, is that I guess that's it, yeah? That's the
But we
voltage
don't.
across the source, across the short, across the points A and B.
No, no. Hold on, hold on. Okay, so you get that. So
1.336 k ohms when I measure the resistance too from that same point.
hold on. 100 over 25 plus 100.
Where are you getting that from?
I'm looking at a different solution.
Okay,
Sorry, I'm just trying to work it out in my head here.
totally.
The fuck do you get that? You fucking god damn it. Times 100. Why the voltage drop? I think this person's high. I don't believe this.
Dude, I feel like some of the YouTubers, the engineer YouTubers, are high because their explanations are just like, what the fuck are they even talking about? Like,
Right? Yeah. 100%. Well, open circuit across AB. VAB somehow equals that. But there's two power sources in that one, and I want to be lazy. Okay. This one's nice. Okay, how'd you get to 2K? It's 1K plus 1K. Okay, so how'd you get to 7.5? Wait, what? Shit, it might actually be 4.7, whatever.
right?
Yeah.
I mean, that's the measure. I mean, the multisim can't lie.
Oh, it would be 4.7. Okay, okay. So, I think
I was
this
just saying,
volt.
you just went mute.
What?
You just went mute for a long time. I was like, so? I was like, did you just like cut off or some shit? I was
I
like
was
looking
I was
around.
thinking I was thinking through it again real quick.
Yeah,
Um, what was our actual number? 4.7,
4.714. Or it was,
7.14.
yeah, yeah. Hmm.
Yeah. So I think it's 4.714. And what I think is going on here, because we have this point right here in our normal calculations, 4.714.
Hmm.
So that would be our initial voltage source plus these two in parallel. Okay. We don't need this. How the fuck do we get the voltage then? Oh, maybe we do need that.
Yeah, because that. Wait, hold on.
Yes, because this equals 2 point, I think you said 86.
Yep,
The
2.86.
voltage drop here, 2.86.
Mm-hmm.
So 4.714 minus 2.86, that looks like a weird number, equals
1.314. Oh, wait, I did it
314.
wrong. Yeah.
1 point, 8,
1.85.
1.85, 1.85. So we know that this point here now is 1.85 volts. That makes sense.
How?
What do you mean how?
I mean, yeah, it makes sense. But I mean, how does that help you figure anything out?
That's what the well VTH is this actually, isn't it?
Yeah. What would
Yeah.
that what does that point for dictate? Z. What is Z?
Z. Well, that's the voltage into the load.
Oh, into the load. Okay. Well, I think we got that part. How did we get 4.714 before that?
That was earlier up here when we did this. Well, when we had the voltage source there.
Oh,
This one. When you did the calculations here. I don't think we actually wrote it down, but
yeah, I didn't write it down. That's why I was like,
1.714. Well, this was the drop, right? The drop was 4.714. It's just this node happened to also be 4.714.
oh, I see.
Who wants to invent a time machine and go kick Thevenin in the fucking nuts?
I definitely do.
Right?
It's like for two reasons. Like, why is your name like that, and why did you discover this rule?
Did you? Fuck your name.
Yeah, seriously. My professor almost sounds like he's saying feminine when he says it at work, at class. He's like he's almost saying feminine's theory. I'm like, what the fuck?
Yeah.
Now
Um,
calculate. Oh yeah. So here's this next one. You see
which
this
one?
question 12. Obtain a variable resistor V load and set it to your calculated value for R Thevenin. I wasn't
Yeah.
reading the whole question properly. I was like, what the fuck am I supposed to do now?
This will prove out our answer. 3
Yeah. So a variable resistor at the at R Thevenin, which is
3 6.
1.336K, and then place it points A and B. Measure the voltage of that. It looks so goofy. 1.572.
What is that?
That's the voltage across the load of this new resistor. Let me show you what I'm looking at. Granted, I know you're not too savvy with multisim, but
I mean, it's a simulation tool. I understand it.
oh yeah, shit, man. I be telling that. I tell my coworkers, they're like, oh, I don't know this shit, man.
Really?
Yeah, they're like, I know how to use like Spice or whatever the fuck that shit's called,
Same fucking thing. Multi-sim is just P-Spice.
bro. I'm about to hit them with the facts. You lazy motherfuckers.
Are you? What is happening?
I'm cutting and
Oh,
screenshot and shit, yeah, because it's bop bop at
oh,
50%. Is that the problem?
hold on. If a load resistor, remove, obtain a set it to your calculator. Oh, okay, okay. Now measure the voltage of the new
Oh
load
yeah,
resistor.
it's because I had it at 50%. Because if I put it at 100%, it's half of uh, the Thevenins. It's half, yeah, Thevenins.
Half of.
It's 2.357 if I put it at 100%.
Okay, I get you. Yeah. This will. Okay. So the next question we'll just do by hand,
Hell yeah.
and I think if what's going on in my head is right, I think this will prove out our answer above. So we get this, we get this. Basically, we got to solve this new circuit. And instead of putting a variable resistor, I'm just going to put a normal resistor here, RL.
Yeah, what would
When,
be the point of making it a variable or a regular one?
I don't know if there's more questions down there otherwise. But
Mm.
oh, maybe I think because he wants you to do this actual lab,
Mm-hmm.
right? I remember one of the questions was like, go grab an actual one and put it on your breadboard.
Yeah,
Um, then that makes more sense to put that there.
totally.
And the rest 2.2K. Why don't you just go ahead and solve this for me? Just give me all the current and the voltages here. I'll do the same. And this is 12 volts, right?
Yeah, 12 volts.
Wow. Oh, my back burns.
You got a foam roller?
I don't know if that'll help. No is the answer, but I still don't know if that'll help.
Oh, that was funny. R1 1.2K. RL 3 1.33. So all the RL R1 through 3 are all going to be factored into the total resistance, correct?
Wait, say that again?
So the 1.2K, the 2.2, the 2.2, and then the 1.336 are all going to be factored into this total resistance that I'm about to calculate, correct?
Yeah.
Okay.
Yeah. Okay.
So that's
This equation again, except for this one.
1.336 plus 2.2.
So far, everything makes sense.
So
Sure.
RL plus R3 equals 3.536. Okay.
Hey,
1.2 plus 2.2. 3.4K. And then 3.4 times
I love the next question. That's great.
3. I'm glad you love it.
I think I probably only got about 30 minutes of brain energy left. I'm getting pretty tired.
Oh, yeah, for sure, dude. Appreciate all your help.
We can do more tomorrow, but fair warning, I might be buzzed tomorrow.
Hell yeah, dude. You know I'm down. You say fair warning like it matters to me. 1 ohm.
Well, I mean, the more drunk I get, the more errors I'm bound to make.
Not really. The more drunk you get, the more you just talk about math that I don't need. Like fucking derivatives and whatever the hell you was going on to in the last session. I was looking at
Yeah,
my notes and I was like, what are these notes that I was writing down? Like this is like some shit I don't even understand. Like
you just wait. All these little side conversations we have, you're gonna step into that math class
dude,
and that upper level the upper level EE class, and you're gonna be like, "What the fuck, punks? I got 100% on all this shit."
dude, I already know. Like one time, I'm just gonna sit in the class. And it's gonna like boom. He's gonna talk about some shit. And we're like, oh man, like you were talking about this shit like 3 years ago in the fucking Discord. Like I know what the fuck this is. Like,
Yep.
all right. So the total resistance I got was 1 ohm.
Say what now?
1 ohm. After I did, so I combined because R1 and R2 are in a series, so that's 3.4K. Then RL and R3 are in a series, that's 3.536K.
Hold
And
up, say that again.
so RL plus R3, they're in a series.
Say that again.
RL plus R3.
RL
RL and
plus.
R3 are in a series. So that was, they add together, right? This 1.336 and the 2.2K, they're not in a series?
No,
No?
look at the circuit.
Oh, they're parallel. I'm a noob. I'm a noob. The 1.2K and the 2.2 are in a series, yes.
Yes. Okay. So let's write the
So,
equation.
mhm,
When all else fails, let's write our equation.
yeah,
Okay.
totally.
We're looking at it from the view of the source here.
Yeah.
Okay. So what is our R EQ total?
So that is R1 plus R2
R1, R2, R3. So R1 plus R2.
in parallel with R3.
You need to
Oh, wait.
say it right.
Wait, hold on. It's not in parallel with. Yeah, it is in parallel with R3, but R3 is in parallel with RL as well, right? Oh, no.
You'll get there. Keep trying.
R1 plus R2 plus R3 in parallel with RL, yeah?
There we go.
Yeah.
There we go. Plus, we'll put the parentheses R3 in parallel with RL.
Mm-hmm.
Okay. And so I want you to still do that math. Okay. This is the answer I got. 0.2. Oops.
You got 8.31. All right, let me see.
831.
Oh, yeah, yeah, 831.
Oh, I'm sorry. I'm sorry. That is just for that. Sorry. That is just for this one, 831.2 ohms.
Oh, that's R3 and
Um,
RL in parallel.
Yep. I actually did not make the calculation, like directly make the calculation for the total. I just used variables the whole way, and it filled in the rest for me. So,
What?
Desmo, man.
Yeah, I don't even know how to use that shit. You sent
I
me a
mean,
link for it, I think.
Excel does the same thing.
I don't know how to use Excel either. I have one of the other MEs that has some script that they wrote to pull out these graphs and calculate the deltas and shit from this thermal test that I'm doing. And I'd be feeling like a beast using it, but I definitely did not make that shit. I'd be showing up like, yeah, here's my report. Here you go. Showing them my
Yeah,
pretty ass graph.
Excel is a hella powerful tool for EEs.
Dude,
Hella powerful.
yeah. All right, let me get this plus R1. So
That's 34, so it should be 4231.
I got 3.4K.
You did something wrong.
I totally did.
3.4K is just this one. 3.4K. That's just these two. So 3.4K plus 831 is going to equal 4231.2.
Yeah, what the fuck? Oh, yeah, I accidentally did 8.31 milliamps or
Yeah.
milliohms. Yeah,
Yeah.
yeah. Okay,
That'll get you every time. And the calculator doesn't know what to do with that. So it just
totally. Yeah, it was just like what?
wants that off. Okay. So now we know what? We know REQ. What's the current then?
Oh wait, hold on.
What?
3.4K plus 831 ohms, right?
Yeah.
Okay, yeah, 4231. Okay.
I did that mentally, so I
Just
wasn't sure I was right.
No, you're right, but I was just tripping over here.
Tripping every fucking day.
Yeah, literally, dude.
Yeah. Okay, so we know REQ. We can redraw this circuit. Um, at some point, you'll probably want to get to the point where you don't need to,
Yeah.
like this, 12 volts. Doesn't have to be now though. And we get
I mean, yeah,
four,
it's
two.
definitely not now. He actually wants us to draw it as part of the assignments.
Okay,
Hmm.
so what's our current here? I total equals, oh gosh, 28-ish milliamps, 2.8-ish milliamps.
2.8, yeah, 2.836. Oh yeah, I
Two
got that. Yeah,
2.8 what?
2.836 milliamps.
That sounds awfully familiar from what we
Yeah,
did earlier.
it totally
Go
does.
figure. Yep. Okay, so we know that current. What's the actual question? V load. Okay, so let's rewrite the circuit then. We get this one, we get R1, R2, back hurts. And now we're going to put only one resistor there because we're going to call this REQ of R load. Okay. Do you understand why I'm
Wait,
doing that?
hold on.
Yeah.
We're doing number 12, or wait, number 13. I mean.
Um, it's measure the voltage of this new load resistor.
Oh, I have that. It's 2.357. Remember? That was the one I showed you right here that I incorrectly did half of. Oh yeah, that's right. But we're calculating it now to get it.
We're calculating it a different way.
Hmm. So wait, we're off then, because if we got 2.836, we're
Ah,
500.
careful. That's current.
Oh.
Don't get confused.
Oh yes,
Technically, we have the answer. I believe your voltage here that you calculated 2.357.
Yeah.
I believe that's what we will get. But let's go through all these steps.
Yeah, let's go through all the steps.
Okay, so REQ of REL. What's this equation?
That is R1 plus R2 plus R3.
I this one, this one, which is oh, son of a bitch. Why did it do that? Which is just these two, right?
Wait. R3 and RL parallel?
Yep. Because we have R1, R2,
Oh, yeah.
REQ of the load
Mm-hmm.
is
Of load, yeah.
R3 in parallel with RL.
I didn't catch that last part. I got you.
Sorry, that's my bad.
No,
And
you're
then
good. You're solid.
oh, from earlier calculation, this equals 831.2.
Mm-hmm.
Okay. Now we have all the information we need to easily calculate this voltage point right here. So why don't you go ahead and do that? We know that this I is 2.3, 2.83.
Yeah, 2.83.
Okay.
6
Mm-hmm. So,
times.
yeah. So this is voltage point A, right? VA. So we know VA equals REQ RL
Mm-hmm.
of the load times
The total current.
by the current. Yep.
Yeah, total current.
I, in this case, it's
And
IT.
you are correct. It is 2.357.
Yep. Great. Equals 2.357 volts. Okay, there's your answer for V load. And now calculate the current through this new load resistor.
Yeah.
Okay, how do we do that? We don't have to redraw the entire circuit to do that.
To calculate the current through this load resistor, so we just calculate 2.836 or 2.863. Yeah, 2.836 by the RL 831. I
Uh,
thought we just did that.
no, we didn't. But you are correct. But you need to be very aware of something here. So
Yeah.
we have 2.357 volts here.
Mm-hmm.
We do have this RL here, or this R3 here, which we don't really care about. But what if we had another resistor here? We couldn't just straight up calculate that down, right?
Right.
But because this happens to be ground, we get the full load
Oh
dropped
yeah,
to
that's right.
5 volts. So we get I equals
Yeah, 2.836.
no. I'm sorry. No, no. I'm still correct. I of RL.
IRL, which
What
is
is the equation?
IRL is uh, VA times RL, isn't it?
Ohm's law.
Divided by.
V
Yeah. Divided by. Yeah,
is my
yeah.
RL.
Yeah, that's what I told you that divided by. Yeah.
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 Yeah. And we know that VA is 2
I like
point.
shrugged at the screen when you said Ohm's law. I was like, what? But yeah, it's obviously
Dude,
too late for me too.
do not ever forget Ohm's law. The very first job I got at Microsoft, my boss was telling me he had a PhD student come in and not know what it was.
Bruh. Yeah,
So
luckily this instructor, he is good at reminding us about Ohm's law. He
yeah,
loves to remind us how much it works all the time.
yeah. And that is like the one thing you'll use on probably like a weekly basis for probably the first 5 years of your career.
Yeah, I hope so, cause shit, I can do me some Ohm's law calculation.
Okay, what's my RL?
RL is 831.2.
Bullshit.
RL is 4.231.
Bullshit.
Wait, what?
RL. I'm not trying to trick you. It's something we defined earlier, isn't it?
RRL is 1.3. 336. Oh yeah, yeah.
Yeah,
1.336 ohms. K ohms.
1,336.
Yeah.
Yep. And so this is going to equal
Two
mm,
point three five seven five
to
four zero.
1.7 ish
Nope.
something.
1.764 milliamps.
Is it milli?
Yeah,
One, two,
because that's
three, four.
kilo ohms. 1.336 kilo ohms. Oh yeah, duh. You have it right there. Yeah, 1.336 ohms.
So 1.7 milliohms? I feel like it's 170 micro. I'm going to double check.
2.357 divided by
Ye- Nope, you're right. Good job.
1.7. All right, go. I say I'm hitting this calculator like
One of
TA89. It ain't that old. It ain't that
Yeah.
bad.
Okay. So now we have the current through the new load resistor.
Yeah, 1.764. All right.
Okay.
Want
Moving
to use this
on.
as a stopping point?
I'm still good for a bit.
Oh yeah, okay. Because this next
Yeah.
one looks like a doozy.
The next one's kind of multiple gas.
Oh yeah, it is. Huh? Oh yeah, it is.
A lot of work to it though, but it's just one question.
Yeah, it looked like hell though.
Yeah. Well, let's just tackle this the best we can and see how it goes.
All right,
Okay. So
give me a sheet of
this
paper.
is huh?
So I'm flipping to a new sheet of paper.
Oh
If you
yeah.
got space, yeah. Build a circuit to AS shown in figure. Let me just create this in multi-center real quick.
Okay.
Two
R3.
voltage sources. I hate superposition too, by the way. Oh my god.
It's pretty easy though.
It's easy, but I can only hear myself talk in the video, so it's it's only half as easy.
I wonder if my neighbors hate me. Fuck them. They're noisy all day.
Yeah, say fuck them.
Well, the ones above me. The ones to my sides, I can't hear.
Dude, are you
I
gonna
was
be
watching.
free this weekend for a sesh? The final sesh?
Um, yeah.
Okay.
I don't see why not.
All right.
I don't. I don't. Sunday for sure. Saturday maybe.
Yeah. Okay. Cool. Cause yeah, it's gonna be your midterm sesh, man. I blazed through that midterm, so I'm hoping to replicate that with the finals. Cause dude, yeah. I
I'm a
sat on that
little.
shit nervous until I did the first question. And I was just like, this ain't shit. 3 hours. I only need 20 minutes. Fuck.
How long did it actually take you?
Like 30-ish minutes. It was
Oh
pretty
my
quick. Yeah,
god!
it was quick.
I bet the instructor was like, "What the fuck are you
Yeah,
doing?"
like he was. They
And
were
he's,
both impressed because yeah, I was like struggling at first, man. I was like, what the fuck is going on?
I mean,
He's like,
it
yeah, I'm
fucking.
using my resources. They say use your resources.
Yeah, yeah. I saw that. I
Yeah.
saw that at the top. Although they do not label friend. Yeah, I guess they do label
No, they
friends as well.
they say don't use the instructors. Use anybody. Yeah, you got a
See,
friend
seek
that's a EE.
assistance from class and teammates.
Hmm.
Request guidance from your TAs or instructors.
Yeah,
I mean, technically, I'm not on there, but
exactly.
whatever.
Yeah, just a friend.
Just a friend. I'm just your private instructor. There we
Exactly.
go.
Yeah,
You get
private
around that.
unpaid instructor.
Yeah.
Fuck yeah. Thankfully, you make 250,000, so you don't feel bad about the unpaid part. Because yeah, I'm sure that a starving engineer would definitely beg to differ.
Yeah, I don't feel like I make a lot because I'm socking so much away into savings because I started so late in my life for generating this kind of money, right?
Fair.
Uh,
Yeah, I was thinking about that too. I was like, man, like, how do you just not sit there and think of like shit you want to buy? Because like, man, when I come up like when I just came up to my measly $30 an hour, all I could do is think like, man, I want to buy this, and I want to buy this, and I want to buy this, and I want to buy this.
bro, I'm literally saving like over half of my paycheck.
Yeah, dude, like I don't.
That's why I'm in this apartment. It's literally $400 less than the other places, but I have to deal with like road noise and fuckers above me, and it's just like, is $400 worth it? And I think, well, that's $4,800 a year.
Yeah,
That's a
exactly.
business class plane ticket to Japan if I really wanted
Oh
to.
yeah, touche, touche.
But yeah,
This is an
it's
easy
it's
setup,
hard
but
not
it's
to
kind of annoying to make.
just spend and spend, and it's even harder now that I bought that car and have a car payment. But
Mm-hmm.
uh, I'm still doing okay. I just
Yeah, for sure. I would imagine you'd have to be pretty irresponsible to start feeling like it hurts at this point. You're.
Yeah, I mean, I'm still like, even if I did nothing different from my previous scenario, which was like eating out all the time,
Mm-hmm.
I'd still be having over $1,000 a month to spend on whatever the fuck I want.
Yeah. Oh yeah. 1 point.
But I tightened up on that a lot and started eating like a lot of salads and shit to lose weight and
How's that
uh,
working for you?
really well.
Doing like I know you're working at home today, but you do any gym sessions like outside at the
Oh
gym or training like Orange Theory or some shit like that?
no, I just tried. Mostly, I just try to walk. I walk after lunch at work. I got a little loop at work that I do. And then I try to do one when I get home. But if it's like raining or nasty out there, I'll just do like indoor stretches and weightlifting and stuff.
Mm-hmm. I need
So,
to start going to the gym. I'm about to sign up for this Active Fit and Direct. You probably have it for your work too, where you can just like bypass the sign up fees and all that shit for any gym, like LA Fitness or those kind of
um,
ones.
so, before COVID, they had something called the Stay Fit program.
Mm-hmm.
They gave you $1,000 a year for whatever thing you wanted that was fitness related.
Oh
You could
damn!
buy like kayaks or something, or gym membership, or you could get into the quote unquote Microsoft gym for that $1,000 plus like an extra $20 per month.
Wow.
But they also have like two Olympic swimming pools in there, and if you have a kid, they have like an hour of free daycare every day.
Oh,
So
that's pretty cool
it's
actually.
it's a lot of perks
Yeah, that's
otherwise.
pretty cool actually. Yeah.
Yeah. They did away with the idea of Stay Fit and made it a Perks Plus. They have some weird rules on it. Like I can't remember which way it is, but you can buy a pet from an adoption center, but you can't buy pet food. Something like that.
That's some
Uh,
fucking weird shit. That's only some Microsoft shit though.
right? And so we get like $1,500 a year for that stuff. I've been using it on private Japanese tutoring lessons.
Oh,
So
smart.
yeah.
Through who?
It's an online thing called Take Lessons. So
Take lessons. You found the most generic ass website to throw your money at? That shit doesn't even sound legit.
it's
TakeLessons.com. Oh, it's powered by Microsoft.
yeah, I was about to say Microsoft owns it. So
Oh,
there's
okay.
the reason I found it.
That makes sense, yeah. That's dope. Is it working well for you?
Yeah, yeah, she keeps me honest. Um, she lives in San Jose, I think it is. And she's actually going to Japan in like a couple weeks, and then I'm gonna just barely miss her. We could actually have met in Japan.
That's dope.
Uh,
Have you ever done the it's like Hello Japan or Hi Japan where you like talk to speakers like locally? It's almost like a dating app, but it's like for like the language exchange.
I'm on one called Hello Talk.
Yeah, Hello Talk. Yeah, boom.
Yeah, yeah. I've been on there for a while, and when I went to Japan last year, I met all of my friends that were actually stuck around.
That's cool as fuck.
Yeah.
Hell yeah. All right, let me go back to this lab where it calculate V Thevenins and R Thevenin. Series parallel circuit 8 volt, 24 volt, 1.2K, 2.2K ohm resistors. Set the circuit R that. So yeah, I have the RL here, so I short the RL. So in this case, I
Wait, what?
short RL, right? to calculate.
What one are you on?
I'm on question 14.
Is it not the circuit I have up?
Yeah, that circuit you have up.
Oh, okay.
Hmm. Yeah. So in this case, I would short both power supplies.
Oh, you said short the resistor
Yeah, I
earlier.
did. I did. I did. But I
I
would.
was confused.
Yeah, yeah. Short both power supplies because I want to calculate the resistance.
Right,
So I want to short the power supply.
right. So now the circuit will look like this. RL, and this is this. Looks like this, yeah?
Yeah.
Okay.
But doesn't it
And
still
then
have three grounds? If I or
they're the same.
yeah, it's the same. Okay.
Sometimes you'll see it like this though. And that's probably why they do it, is you'll see it like this.
Yeah.
Yeah. I mean, I see it like this in our schematics all the time. So 1.2K. Now, remember, we're looking at it from R4's perspective or RL's perspective, right?
Yep.
We're looking at the resistance going that way.
So that means it's in parallel with both of them, right?
You need to be very specific with what you just said
It should
because
be
that
RL. Uh.
R2.
Um.
Let's write the equation.
Yeah.
So why does it do
REQ
that? I don't know why it does.
equals.
Not REQ. R Thevenin
Thevenin.
equals what? You can keep it in R format. We don't have to use the actual numbers.
Um. R1. Wait. Yeah. What would it be? Shit.
We're looking at it from the load's perspective outward.
And it could go both ways from there. If the
So
load is.
therefore,
So it's parallel with both. So it's your
not,
typical. No.
parallel is not the right word, but you're on the right path.
How would I calculate it? Like the inductance one, right? 1/1.2 plus one
No,
over 2.2.
yes, you're correct. I think you have the right idea. You just said it wrong.
Because that's how you calculate the inductance.
Inductance.
One over.
Inductance in parallel?
Inductance is the opposite of resistance, right?
Not really.
No. What? What is it? G is
Induct
inductance, right?
L
L. What is G?
G G.
Yeah. Conductance.
Isn't conductance like rho? Conductance is Siemens, isn't it?
Yeah.
Conductance is
G.
Siemens.
Yeah. Yeah. Siemens. Yeah. Yeah.
Okay.
Okay. So it's conductance. I was thinking of one
Yeah.
over one over R.
Okay. We don't need to go into that deep here.
Oh, so how do I calculate the parallel resistance, the total resistance in this parallel?
You said it, but you got to be very specific in what is in parallel
They're all in parallel.
from the viewpoint of the load.
Oh,
I
so
think
which way would the current be flowing? Is the question, I guess, to
you,
dictate which one's in the series.
what if we rewrote the circuit?
Maybe it would be easier for me to understand. Yeah,
God damn it! Why does it do that? Some
Microsoft. That's why.
reason,
It's not Apple. That's why.
sometimes I put my thumb to the left, and all of a sudden it's going to just jump all the way to the left. I don't get it. So what happens if we put a ground up here, doop doop, and we put our load here, and we put R3 here, and then I put R2 and R1.
Oh shit! I didn't even see R3 right there, dude. Oh my god. Yeah. So it'd be.
That was the problem. Okay.
I was like, what
No,
the?
I honestly mean that. I wasn't trying to poke at you.
No, you're not. No, trust me. You have never insulted me. I don't feel anything yet. But yeah, yeah. What the fuck? I didn't even realize that shit. I was like, man, what the hell? All right,
Would you
so
agree, before we go any further, would you agree that this drawing here is an equivalent representation of that?
yes, and a much better visual representation of it too.
Okay. So,
That would be
but
RL plus R3 in parallel with R1 plus R2.
you almost got it.
Wait,
Remember, R Thevenin, it means no RL.
no RL?
Yeah.
That's right. We got a short RL for R Thevenin.
So R3 plus R1 in parallel
R1 in parallel with
R2.
R2.
Okay, now that we have that down, we get 1.2K plus 1.2K in parallel 2.2K. Let's see here. This will be 800 and
You're doing that in your head, bro?
God, I think it's the same one as before, isn't it? 830 something. 3 and 1. R3 in parallel with R. No, it's not. That's unfortunate. It'll still be like 790-ish. That's my guess. I'm hoping you're doing this in the background. I'm not doing
1.976. I think I might have did it wrong. Wait, yeah. 1.2K plus.
it.
Yeah,
1.2
1.976K.
2 divided by 2 plus 2.2. Nope.
No?
Nope.
Alright,
That
let me
was
do
pretty.
1.2 E3 times 2.2 E3 divided by 0.2 E3 plus 2.2 E3. 7.5. 776.5 plus R3 is 1.2K.
Well, you're doing the whole thing. I was just asking what this was.
Oh, 776.5 ohms for that one.
Good, good, good. 776.5.
Yep.
Okay, good.
And
So
then the
that
total is, yeah,
seven.
1.976K.
Yep.
Yeah,
Good, good.
gotcha.
Okay.
Okay, so I was tracking. I just was going a little further ahead.
Now, I don't necessarily know how to do this with two circuits. uh,
Superposition. We would just. Oh, yeah, I know, right? That's what I'm like, what the fuck?
so now, this is like school bullshit here that I'm teaching you. Maybe I shouldn't. If we look at the answers to the question, because it's multiple guess, right?
Mm-hmm.
We have R Thevenin here, which is 2K.
Yeah,
Yeah, there's only two answers with 2K.
that's true.
Huh? And now we need to figure out what's the voltage going through there. Okay. So now, how do we do that with two fucking voltage sources?
It's 12.5, right? Or 13.65.
I have no
24
idea.
minus 8. No, maybe not. Yeah, I don't know why it's obviously. When building a board, measure that. So what would be V Thevenin if we just did it with the 8 volt? And then what would be V Thevenin if we did it with a 24 volt? And then we'd calculate the difference there, like a superposition.
I wonder. Yeah. Okay. Why don't we just try it and see what happens?
Yeah, maybe.
So we get essentially this circuit, right? This is 2K
8,
and this. Yeah.
8,
24,
1.2,
8.
and then 1.2.
No, no. Just this. Remember? You think we should put
Oh
the
yeah.
1.2 in there?
No, you're
I
right.
don't know.
Yeah.
So 12. Is that an answer? 12.5 is an answer.
12.5 is an answer.
I do not know how to do this, my friend.
I don't. It's all good.
Oh, here's one. Found like this exact problem here. Resistances removed. Okay, I get it. Okay, backtracking.
This dude. I wish I could just look at a problem and just be like, I get it. I look at a problem just like, I'm gonna do something else.
Okay, so we have this. This is still correct, right?
Yes.
And then we have to open RL, right?
Yeah. So that would be
So
zero
we
right
have
there.
R, what is this, R3?
Hmm.
And then we have an open right there, like that. Okay, R2 and R1. So now let's do superposition on this circuit. Right?
Yeah.
This is 2.2K, I think, and then this is 1.2K. And then this is whatever this is, 1.2K. I guess it doesn't matter.
1.2.
Now,
2.2.
careful. Don't just slam shit into your calculator. You're going to make a mistake.
I am totally am.
What's the one concept thing you need to notice here that will save you? If we look at superposition, let's look at superposition from this 24 volt real quick.
Hmm.
What's our current path? Or maybe a better question is, how many current paths? If you can answer that, then I know you understand.
There's one. One. There's two.
Okay, you don't understand. This is open circuit, is it not?
Yeah.
So therefore, there's only one current path.
Oh yeah, that's right. It doesn't go. I don't know why I was thinking it would go to the end of R3 and bounce back. Okay. Because I
Yeah.
was like, I know it's open right there. But
Yep.
it theoretically does do that, right? Electrons. We just can't measure
Yeah.
it that way.
So actually, what will happen is whatever this voltage is right here.
Hmm.
Like let's just say, for instance, it's 10 volts. This point here will also be 10 volts.
Yeah.
And there's a lot of other theory and stuff behind that, but this essentially acts as like a small capacitor.
Hmm. Oh.
Yeah.
Okay. So they are
So
there. They just can't be.
they're there. They just don't go that way.
Gotcha.
Okay.
See, that shit is the fascinating part of electronics. It's like
Yeah.
it really
Like,
shows you that like shit that you can't see is there.
yeah. No kidding.
Yeah.
Okay. So what's our current here? I'm going to speed up a little bit because
Yeah.
it's like 11:10. So we get 24 volts over R2 plus R1, which is 3.4K.
Hmm.
And that equals something. That equals 600 and some odd milliamps. 60 milliamps, something like that.
7.059 milliamps.
4 divided by 3. 7 milliamps. Okay. 7.06 milliamps. Great. And then what's our other current path here from the 8 volt? Well, we go this way, right?
8 divided by
8 over 3.4 should be
2.53 2.353 milliamps.
353 milliamps. Okay, that's great. Now, what do we know here? We know that we're pushing this way, right? If we look at each resistor. So our overall current is going to be 7.06 milliamps minus 2.35 milliamps in
4.7.
that direction. 4.7 milliamps?
4.706, yeah.
0.6. Okay. So now we know what our current is. That way, 4.7, whatever you said,
4.706. Yeah.
6 milliamps. And then we have our battery, 24 volts. It goes this way. I wonder if we actually needed that. This might be wrong. Because we actually have to account for this battery too in a different way. Now, we have all these resistors. We have our load here. This resistor here, R2, I think, 2.2K. 2.2K. 1.2K. Okay. What is our voltage here when we think of current this way?
It is 24 volts.
No.
No. Wait.
Nope. We need to do the loop again. This loop up here, super style.
Wait. You're asking for 24 volts, though, isn't it?
No. What's the voltage here? So let's go back up to this one.
Okay.
We know our current going this way is 7.06 milliamps.
Mm-hmm.
So what is our voltage at this point here? I'll use red. This point here.
I have no idea.
So we can do current, or we could do a voltage divider. I like voltage dividers. 1.2K over 3.4K. That's 1.2 plus 2.2 times 24 volts.
1.2. 3.52. Oh, times 24 volts?
Yep.
8.471.
8.471. And then we do the same thing going the other way. We do 2.2K over 3.4K times 8 volts. And that will equal something. 22 divided by 34 times 8.
5.176.
176. And now, I bet you if we add those, let's see, 8.47.
13.65.
5.17.
12.
Yep, 13.65. We have our. There's no other 13.6. Yeah.
No, there's
So we have
another
our.
one, yeah.
Yep.
Damn.
There you go.
What the fuck? Well, shit. Okay. I think I could do these rest of these tomorrow during work. Sneak a couple questions out with the information that I got. It saves all the answers that I put in. So.
Okay, and we can do more tomorrow night. That's fine.
Hell yeah, I appreciate it.
Yeah.
Sick. All right.
All right, man.
Thanks, bro.
I'm gonna go sleep.
Yeah. Likewise.
Yeah.
Yeah.
Catch you later.
Later, bro. Take it easy.